Betelgeuse, often referred to as a red giant star, is so massive that if placed where the Sun is, it would extend out to the orbit of Jupiter. This enormous star is highly unstable and on the verge of exploding. Brian Cox, the renowned physicist, has recently made a groundbreaking revelation that has stirred both the scientific community and the general public. According to Cox, the massive red supergiant star Betelgeuse is on the brink of a colossal explosion, predicted to occur within the next 2 weeks. While the explosion is not expected to be catastrophic for life on Earth, its sheer magnitude and potential to reshape our understanding of the universe are monumental. The implications of this stellar explosion are profound, offering immediate observational opportunities and longer-term impacts on astrophysics and human curiosity about the cosmos. Before delving into the details, please don't forget to like and subscribe to our channel for more updates. Betelgeuse, located in the constellation Orion, has long fascinated astronomers due to its volatile nature. As one of the largest stars visible to the naked eye, Betelgeuse's immense size and brightness have made it an object of awe and study for centuries. However, in recent years, the star has exhibited strange behaviors, such as dimming unexpectedly and then brightening again. These fluctuations in brightness have led scientists to speculate that Betelgeuse is nearing the end of its life cycle, poised to go supernova. Cox's revelation has added an unprecedented level of urgency to this speculation, as the final moments of this giant star are now believed to be just weeks away. The notion that Betelgeuse will explode within 2 weeks has sparked a flurry of activity in observatories worldwide. Scientists are preparing for what could become one of the most closely studied supernovae in human history. As a red supergiant, Betelgeuse's explosion will be classified as a Type II supernova, which occurs when the core of a massive star collapses under its own gravity, releasing a tremendous amount of energy. This energy, released in the form of light, particles, and radiation, will be visible from Earth without the need for telescopes. In fact, when the explosion occurs, Betelgeuse is expected to outshine every star in the night sky for weeks, possibly even rivaling the brightness of the moon. This rare phenomenon will provide astronomers with a treasure trove of data, enabling them to study the inner workings of supernovae and the death throes of massive stars in unprecedented detail. One of the most intriguing aspects of this imminent explosion is its potential impact on our understanding of cosmic distances. Betelgeuse is relatively close to Earth in astronomical terms, located about 642 light-years away. The supernova will give scientists a chance to refine their models of stellar distances and the behavior of light and energy across vast stretches of space. By studying how the energy from the explosion travels and interacts with the interstellar medium, scientists will be able to make more accurate measurements of the distances between stars, potentially refining our knowledge of cosmic distances on a grand scale. While the explosion of Betelgeuse is not expected to harm life on Earth, it will undoubtedly have a profound effect on our planet's upper atmosphere. The massive influx of energy from the supernova, especially the burst of neutrinos and cosmic rays, will interact with Earth's magnetic field and atmosphere in ways never experienced before. Although these interactions are not expected to cause any major disruptions to human life, they could significantly affect satellite communications, power grids, and other technologies reliant on the stability of Earth's electromagnetic environment. Additionally, the influx of charged particles from Betelgeuse's explosion could trigger more intense auroras, expanding the range where these dazzling light displays can be seen on Earth. The cultural and psychological impacts of Betelgeuse's explosion should not be underestimated. For millennia, humanity has gazed up at the stars with wonder. The sight of one of the brightest and most well-known stars suddenly disappearing from the night sky could have a profound effect on how we see ourselves in the universe. Some may view the explosion as an omen, while others may be inspired by the spectacle to take a deeper interest in astronomy and the mysteries of the cosmos. The visibility of the event will likely captivate people from all walks of life, sparking conversations about our place in the universe and the fragility of the celestial bodies we've grown accustomed to seeing in the night sky. For scientists, Betelgeuse's explosion is a once-in-a-lifetime event. Supernovae, especially those visible from Earth, are exceedingly rare, and the opportunity to study one this close to home is an unparalleled gift. The data collected during and after the explosion will likely fuel years, if not decades, of research. By studying the light curves, neutrino emissions, and other byproducts of the explosion, astrophysicists hope to unlock new insights into the life cycles of stars, the formation of heavy elements, and the role that supernovae play in seeding the universe with the building blocks of life. These studies could even help refine models of how our own sun will eventually die, albeit in a much less dramatic fashion. In the weeks leading up to the explosion, excitement within the scientific community is palpable. Teams of astronomers are coordinating their efforts across the globe, ensuring that the explosion will be observed from every possible angle. This coordination is crucial because supernovae are not static events. They evolve rapidly over time. While the initial explosion will produce a brilliant flash of light, the real science will occur in the minutes, hours, and days that follow. The behavior of the shock wave, the dispersal of material into space, and the cooling of the remnant will provide critical information about the mechanics of stellar explosions and the fate of stars after they die. Betelgeuse's explosion also offers a rare opportunity for collaboration between professional scientists and amateur astronomers. Given that the event will be visible to the naked eye, anyone with an interest in the stars will be able to witness the supernova, and some amateur astronomers may even contribute valuable observations. This kind of large-scale event brings people together in a unique way, transcending borders and disciplines. The collective effort to observe and understand Betelgeuse's final moments will likely stand as a testament to humanity's shared curiosity about the universe and our ability to come together in the face of cosmic wonder. Though Betelgeuse's explosion is not expected to have catastrophic consequences for Earth, it will serve as a powerful reminder of the immense forces at work in the universe. The energy released by a supernova is almost incomprehensible, yet these explosions are a natural part of the life cycle of stars. In fact, supernovae are responsible for creating many of the elements that make life possible, including the iron in our blood and the oxygen we breathe. In a very real sense, we are all made of stardust, and Betelgeuse's explosion will be a dramatic illustration of that cosmic connection. The explosion may also prompt new discussions about humanity's future exploration of space. As we continue to send probes and astronauts deeper into the solar system and beyond, understanding phenomena like supernovae will become increasingly important. These massive explosions can pose a threat to spacecraft and space-based technologies, and understanding their mechanics could help us better prepare for future missions. Furthermore, Betelgeuse's explosion might reignite interest in the search for extraterrestrial life, as supernovae play a key role in distributing the elements necessary for life throughout the universe. In the immediate aftermath of the explosion, the night sky will look dramatically different. Betelgeuse has been a fixture of the constellation Orion for as long as humanity has recorded the stars, and its absence will be a stark reminder of the transient nature of the universe. However, Betelgeuse's death will also mark the beginning of a new phase in the universe's life. The material ejected from the supernova will eventually coalesce into new stars and planets, continuing the cycle of creation and destruction that has shaped the cosmos for billions of years. In this sense, Betelgeuse's explosion is not just an end, but also a beginning. As the weeks pass and anticipation builds, scientists, amateur astronomers, and stargazers alike are preparing for the moment when Betelgeuse finally reaches the end of its life. It will be a moment both awe-inspiring and humbling, reminding us of the incredible forces that govern the universe and our small place within it. While Betelgeuse's explosion may only directly impact Earth in terms of light shows and minor disruptions to technology, its effect on our understanding of the cosmos will be profound and far-reaching. We stand on the precipice of this historic event, ready to witness one of the most significant astronomical events of our time. As the clock ticks down toward Betelgeuse's imminent explosion, the world prepares not only for a spectacular celestial display but also for a wealth of scientific discovery. This supernova promises to be the most well-documented stellar event in human history, providing a unique opportunity to observe one of the universe's most powerful phenomena in real time. Given that Betelgeuse is one of the closest massive stars to Earth, scientists will gain insights into the death of stars and the mechanics of stellar explosions that would be impossible to obtain from more distant supernovae. The significance of Betelgeuse's explosion cannot be overstated. The significance of Betelgeuse's impending explosion cannot be overstated. While supernovae have been observed in other galaxies, None in recent memory have occurred so close to Earth. This proximity means the explosion's energy and light will be considerably more intense and vivid than those seen in previous events. From an observational standpoint, the level of detail expected to be captured will revolutionize our understanding of these cataclysmic events. As the explosion unfolds, astronomers will have the chance to observe and measure the precise moment of the star's core collapse, a phenomenon usually shielded by layers of cosmic dust and gas. This rare clarity will allow scientists to better understand the processes leading to a star's violent death. One of the most important scientific goals of the upcoming explosion is to gather data on the neutrinos expected to be emitted in massive quantities during the supernova. Neutrinos, often called ghost particles because they rarely interact with matter, are among the most elusive and mysterious particles in physics. During a supernova, a tremendous amount of energy is released in the form of neutrinos, and because they travel faster through dense matter than light, they are likely to reach Earth before the explosion becomes visible. This will give scientists a head start in detecting and studying the event. Neutrino detectors around the world, such as Japan's Superkamiokande and the IceCube Neutrino Observatory in Antarctica, will play a critical role in capturing these particles, providing unprecedented insights into the mechanics of a supernova. Another aspect of Betelgeuse's explosion that will be closely studied is the formation of new elements during the supernova process. When a star goes supernova, the intense pressure and heat generated in the explosion lead to the creation of elements heavier than iron, such as gold, silver, and uranium. These elements are scattered across space, seeding future generations of stars and planets with the raw materials necessary for life as we know it. By studying the specific light signatures emitted during the explosion, scientists will be able to identify the elements being produced in real time, offering a clearer picture of how the elements that make up our solar system, and even our own bodies, came into existence. As Betelgeuse prepares to explode, astronomers are also keen to study its surrounding environment, particularly the massive clouds of gas and dust the star has ejected over its lifetime. Betelgeuse is known to be surrounded by an intricate structure of stellar wind and debris, remnants of its intense stellar activity over millions of years. When the supernova occurs, the shock wave from the explosion will interact with this material, heating it up and causing it to glow in various wavelengths of light. This will provide scientists with key data on the star's evolution, its mass loss history, and the way it has shaped its local environment, crucial for understanding the life cycles of massive stars destined to end in such a dramatic fashion. In addition to its scientific implications, Betelgeuse's explosion will have a profound effect on public interest in astronomy. This event will be unlike any celestial phenomenon most people alive today have witnessed. The brightness of the supernova is expected to rival that of the full moon, making it visible even from the most light-polluted cities. Such a visible event will likely inspire a new generation of stargazers and scientists. The media coverage and public fascination with the event are expected to spur renewed interest in space exploration and understanding the universe beyond our planet. Schools, universities, and planetariums are already gearing up for this influx of interest, designing educational programs to help the public understand the science behind what they are witnessing in the night sky. There is also growing excitement within the amateur astronomy community. With modern technology, anyone with a camera and basic telescope will be able to document the supernova as it unfolds. This democratization of science means thousands of people across the world will contribute to the collective understanding of this event. In past centuries, when supernovae were observed, only a select few had the equipment or knowledge to record them. Now, with digital photography and widespread access to information, the global community can come together to witness and record the death of this star. The explosion will also benefit space-based observatories like the Hubble Space Telescope and the James Webb Space Telescope. These observatories are already positioned to observe the universe in a range of wavelengths, from visible light to infrared and ultraviolet. Once the explosion begins, these telescopes will capture images and data impossible to obtain from ground-based telescopes, particularly since Earth's atmosphere filters out certain wavelengths of light.